Welcome to Kubernetes with Typical Monk, Class 1, Why Kubernetes, and where this course will take you. Imagine you have built an application, packaged it neatly into containers, and now you need to run it, not one copy, but hundreds, spread across many servers, staying up around the clock. Who starts them all? Who restarts the ones that crash at 3 in the morning? Who adds more when traffic surges, moves them when a server dies, and wires them all together so they can talk? Doing that by hand is simply impossible at any real scale. Kubernetes is the answer the whole industry settled on, an open source system that runs and manages your containers for you automatically, so your applications stay running, healthy, and reachable without a human standing guard. It has quietly become the operating system of the cloud, the standard skill for anyone who deploys modern software. Whether you end up as a developer, a DevOps engineer, a site reliability engineer, or a cloud architect, Kubernetes will almost certainly sit somewhere under your work, which is why the hours you invest here pay off across your entire career. Over this course, we will go from your very first pod all the way to designing production clusters, one idea at a time. The architecture, the core objects, workloads, networking, storage, scaling, security, and operations, preparing you for both the CKAD and the CKA certifications, in Hindi and English together. Today, the map, what Kubernetes solves, how a cluster is built, the objects you will use every day, where it came from, and the road ahead. One idea at a time. Here is the map of today's class. 6 ideas that turn Kubernetes from an intimidating name into something you can actually picture. First, what Kubernetes really solves, the problem it was born for. Second, cluster architecture, how a Kubernetes cluster is built and what each piece does. Third, the core objects, pods, deployments, and services, the vocabulary you will use every single day. Fourth, where it came from and why it won the orchestration war. Fifth, CKAD versus CKA and the shape of the two exams. And sixth, the course roadmap, the path from your first pod to a production architect, one idea at a time. Let us start with the problem, because Kubernetes only truly makes sense once you feel the pain it removes. Containers, which you may know from Docker, are wonderful. They package an app so that it runs the same way everywhere. But a single container on a single machine is fragile. If that machine dies, your app dies with it. And if a million users suddenly arrive, one container cannot possibly serve them all. Now picture running hundreds of containers across dozens of servers. Someone has to place each one on a machine with room to spare, restart it the instant it crashes, replace it when a whole server fails, add more copies when load rises and remove them when it falls, and keep track of where everything lives so the pieces can find each other. That someone, done by hand, would be an army of engineers awake all night, and they would still be far too slow to keep up. Kubernetes is that someone turned into software. You tell it the state you want, and it works tirelessly to make reality match, healing and adjusting entirely on its own. So the takeaway, Kubernetes keeps your applications running, healthy, and reachable, automatically, without a human watching, which is exactly what running software at real scale demands. This idea has a name you will hear constantly: declarative management. You do not tell Kubernetes how to do each step, you declare the end result you want, and it figures out the how, and keeps it that way even as machines fail around it. So how does Kubernetes actually do all of that? To understand it, you need its anatomy, and a Kubernetes cluster has 2 halves that work together. Let us build the picture, piece by piece. At the heart is the control plane, the brain of the cluster. Its front door is the API server. Everything you type and every component in the cluster talks through it. When you want something to happen, you ask the API server, and it is the single point everyone trusts. Behind it walk 3 more parts of the brain. etcd is the cluster's memory, a reliable store that holds the desired state of absolutely everything. The scheduler decides which server each new pod should run on, based on where there is room. And the controllers watch constantly, comparing what is with what should be, and quietly fixing any difference they find. This is the self-healing you keep hearing about. made real. Then comes the other half, the worker nodes, the muscle, the machines that actually run your applications. On every node, a kubelet takes orders from the control plane and runs the containers. A kube proxy handles the networking, and your pods, your running containers, live right here. So the takeaway, a cluster is a control plane that decides, and worker nodes that do. The brain sets the desired state, and the nodes carry it out over and over, automatically. Here's the beautiful part of the design. The control plane never stops checking. If a pod on a node dies, the controllers notice within seconds and ask the scheduler to start a fresh one, somewhere healthy. No alarm, no human, just quiet, constant correction. Now the vocabulary. Because you do not command Kubernetes by clicking buttons. You declare what you want using a handful of objects. Master these, and you can read and write real Kubernetes. Let us meet the essential ones. The smallest is the pod, the basic unit Kubernetes runs, wrapping one or more containers that belong together. But you rarely create pods by hand, because on their own they do not heal. So instead, you use a deployment, which manages a set of identical pods for you. It keeps the number you asked for alive, replaces any that die, and rolls out new versions smoothly, with no downtime. Pods come and go and change addresses constantly, so to reach them reliably, you need a service. A stable network endpoint that always points to the right pods, no matter how they move or restart. This solves a genuinely hard problem. In a world where your pods are constantly being replaced, the service gives the rest of the system one steady address to rely on, so nothing breaks when the pods behind it change. And to configure them, config maps and secrets hold your settings and your credentials separately from the code, the way good design demands. Two more give you structure. A namespace lets you isolate and organize resources, cleanly separating teams or environments inside one shared cluster, and an ingress routes outside traffic in, deciding which incoming web request should reach which service. So the takeaway, pods run your containers, deployments manage them, services expose them, and config maps, namespaces, and ingress round out the toolkit. And every single one of them, you simply declare in a plain text file in YAML. That YAML file is the heart of the whole philosophy. It is a written description of the state you want, which you can save, share, review, and version like any other code. Which is why people say Kubernetes turns your infrastructure into something you can manage like software. It helps to know where such a powerful system came from, because its history explains its unusual strength. Kubernetes was born inside Google, which had been running nearly everything in containers for over a decade, using a secret internal system called Borg. They had learned, at a scale almost no one else had reached, exactly how to orchestrate containers well, and what goes wrong when you do it badly. Very few companies on Earth had ever run computing at that scale, which is why Kubernetes did not arrive as a fragile experiment. It arrived carrying the scars and lessons of a system that had already run Google's search and Gmail for years. In 2014, Google took all of that hard-won experience and released Kubernetes as free, open-source software, a genuine gift to the world, and also a shrewd move, because it quietly made Google's way of working the whole industry's way. Then, crucially, they handed it to a neutral home, the Cloud Native Computing Foundation, the CNCF, so that no single company would own it. That neutrality is precisely why every cloud provider embraced Kubernetes, rather than fighting it with a rival of their own. So the takeaway, Kubernetes grew from Google's Borg, was open-sourced in 2014, and became the neutral CNCF standard, decades of battle-tested wisdom, handed to everyone. That origin is a reassurance for you as a learner. You are not betting your career on a passing fad, but on a system proven at the largest scale in computing, and adopted as the standard by the entire industry. For a few years, there were several rival orchestrators competing to become the standard. Kubernetes won, and won decisively, and understanding why tells you what truly matters in this world. It did not win merely on features. Its competitors often had comparable ones. It won, first, on ecosystem, a vast and fast-growing collection of tools, add-ons, and integrations built up around it, so that whatever you needed someone had very likely already built it. It won second on extensibility. Kubernetes was deliberately designed to be extended, letting you add your own custom objects and behaviors, so it could bend to needs its own creators never imagined. And above all, it won on community, a massive, open, global community of contributors and users, backed by every major cloud provider, which made it the safe, future-proof choice for any serious organization. Features can be copied in a quarter, a thriving community cannot. Practically, this means when you hit a problem at midnight, thousands of others have hit it before you and written down the answer, and that shared knowledge is worth more than any single feature a competitor could advertise. So the takeaway, Kubernetes won on ecosystem, extensibility, and community, not merely on features, which is exactly why learning it is an investment that will keep paying you back for years to come. This course prepares you for certification, and there are two that matter. So let us be crystal clear on the difference, because it shapes your whole journey. The first is the CKAD, the Certified Kubernetes Application Developer. It is about using Kubernetes to ship applications, defining pods, deployments, and services, configuring them well, and getting your app running smoothly on a cluster that someone else operates. It is the developer's view. The second is the CKA, the Certified Kubernetes Administrator. It goes a level deeper into running the cluster itself, installing it, managing nodes, networking, storage, and security, and troubleshooting when things break at 2 in the morning. Where CKAD is the builder, CKA is the operator. Both are highly respected by employers, and together they signal something powerful, that you can not only put an application onto Kubernetes, but keep the whole platform beneath it alive and healthy. The good news is that the two share a large common foundation, and this course deliberately prepares you for both. First, the application developer skills, then the administrators, so that you finish able to both build on Kubernetes and run it yourself. So, the takeaway, CKAD is about shipping apps on Kubernetes. CKA is about running the cluster itself, and this single course preps you for both, in the right order. Now, what do these exams actually feel like? Because they are quite unlike most certifications you may have taken before. Both the CKAD and the CKA are entirely hands-on. There are no multiple choice questions to guess your way through. You are given a real, live cluster and a set of tasks, and you must actually perform them yourself at the command line while the clock runs. Your main tool is kubectl, the command you use to talk to a cluster, and you will be creating, fixing, and inspecting real resources under time pressure. Each exam runs about 2 hours, and every mark is earned by doing, not describing. And here is a friendly surprise. They are open book. You are allowed to use the efficient Kubernetes documentation during the exam, because in real life, of course, you would too. They are testing whether you can genuinely do the job, not whether you have memorized every last flag. This format is a gift to honest learners, because it rewards exactly the skill that matters on the job. Moving quickly and correctly in a real terminal, and it is impossible to fake by cramming the night before. So the takeaway, both exams are 2-hour hands-on kubectl tests, open book and remote proctored, which means the only way to pass is to practice for real. Exactly the way this course will have you do. Class after class. Finally, let us see the whole road at once, so every class ahead has its place. This course is 10 modules, climbing steadily from your very first pod to a production architect. We begin with the foundations, containers, the cluster architecture we glimpsed today, and your first workloads, the solid ground that the CKAD is built upon. Then we go deeper into the daily work, configuration, storage, networking, and services, and then scheduling and scaling, the true heart of running real applications reliably. And finally, we reach the administrator and architect level, cluster operations, security, and production design, closing with dedicated preparation and full mock exams for both the CKAD and the CKA. So the takeaway, 10 modules from basics to architect, mapped onto CKAD, then CKA, then focused exam prep, each one building carefully on the last, so that by the end, Running Kubernetes in production genuinely feels natural. And do not be intimidated by the word architect at the end of that road. Every architect started exactly where you are today, with a single pod and a little curiosity. The only difference is the steady climb, which we take together one module at a time. Let us gather the whole class in one breath so it locks into memory. Kubernetes keeps your applications running, healthy, and reachable, automatically without a human watching. A cluster has two halves, a control plane that is the brain, and worker nodes that are the muscle. You command it by declaring objects, pods run your containers, deployments manage them, and services expose them. It was born at Google as Borg, open sourced in 2014, and is now the neutral C and CF standard. It won on ecosystem, extensibility, and community, and its two certifications are CKAD for shipping apps and CKA for running clusters. Both exams are 2-hour, hands-on kube-cutter tests, open book, and this course prepares you for both across 10 modules. Next class, from containers to orchestration, a Docker recap, so the foundation is rock solid, one idea at a time. The operating system of the cloud. Not long ago, running software at scale meant racks of servers tended by teams of engineers awake through the night, restarting things by hand. Kubernetes changed that forever by turning the endless manual work of keeping applications alive into something you simply declare and then let the system handle. You describe the state you want, and the cluster tirelessly makes it so, healing and scaling entirely on its own. That single shift, from commanding every step to declaring the desired state, is the idea at the very heart of everything we will learn. And it is why Kubernetes became the standard skill of modern infrastructure. From here we build steadily. The objects, the workloads, the networking, and the operations that carry you all the way to both the CKAD and the CKA. Next class, reconnect the dots from containers to orchestration with a Docker recap. One idea at a time. Welcome to Kubernetes.